Okay, let's take a look at a typical digital multimeter that would be used in the automotive service industry. This particular meter, the Fluke 87, has a lot of features that we may not be using in this course, and so we'll not cover every feature. We're just going to cover the basic features of this meter. And there's really two things we've got to look at: is the selector switch in the center and the ports at the bottom. Now obviously we'll be using this to measure voltage, resistance, and current. And at the very basic level, we'll look at voltage. Our selector switch would go to the second V. This first V has a wavy line, that's AC voltage. We want to go to the V with the solid line on top, that's DC volts. We're going to use the COM port, will be our ground wire. We'll keep a black wire, the ground wire, in the COM port at all times. And in most cases, that's going to go to the ground or the lower side of a voltage potential. But we'll always leave a wire in the COM port. When you're in voltmeter mode or ohm meter mode, you'll also use this red port to the right hand side. This is where you would keep the lead unless you're going to do amperage. So to measure volts DC with a flat line, black line the COM port, a red lead in the red port, and then we'll get a readout up here. You look at your readout, you have to look to the right hand side to look at your multiplier. You may see a small m in addition to, in this case, a V for volts. You can see a small m, which means milli. That means whatever you see needs to be multiplied times 1,000, or move the decimal point 3 points to the left to get the answer. You could see a K for kilo, which means you take the number you see and multiply it times 1,000, or move the decimal point 3 places to the right. Or you could see a large M, which is a mega, which is a million. It means you would move your decimal point 6 points to the right. So when you get your number here, you've got to look to the right and make sure there's no multipliers there for your answer. If we go on to ohms, two more positions, the ohm sign, here again, COM port here, and then here on the red port, you get your two leads. Now you'll notice we're getting OL on the screen right now because we have no connection here, and the meter's trying to measure resistance actually of the air, and it's going to outer limit or over limit. We see a big M, which means it's mega. Basically means it's measured as high as it can, and it's still higher than that. If we put our two leads in here, hook them together, we get close to 0 for no resistance. Now when you use this as a voltmeter, you're going to use the COM port and this meter goes into a circuit in a parallel relationship. It's going to touch the circuit in two places. Do not open the circuit up. Also in the voltmeter mode or the ohm meter mode, there's going to be high impedance. This will not allow or pull any current off of the existing circuit to skew your numbers. When the big difference here is when we go to measure current, come up here to the A for current, for amps. We leave the COM port plug here and move a red lead over to the port over here. This A port and this COM port are on a bus. Inside this meter there's actually a copper bus, and so there is absolutely no resistance to the circuit when you use the ammeter. That's the whole idea of ammeter, becomes part of the circuit and does not affect the circuit. And so when you use this meter in ammeter mode, when you got a port, a lead in the COM port and a lead in the amp port, you can think of this meter as a solid piece of wire. It is a dead short because internally there is a bus. It has a winding around the bus to pick up the inductive magnetic field, and then tells you the current. Here again, got to go to the amp mode on the multi-selector mode switch, and then go to the amp port here. Here again, you'll be looking at milliamps or regular amps. You're not going to have kiloamps or mega amps, but you need to look at your multiplier in all cases to see, what your final answer is going to be. Remember, ammeter mode, this goes into this circuit, and it's going into a circuit that has controlled current. If this is used in ammeter mode, and you put this across a load, you will short the load out because this behaves as though it's a solid piece of wire. So when you use this in a parallel fashion and go across a load, you will actually bypass that load, and then most cases, if there's nothing else in the circuit, you have a dead short to ground. And the problem here is you have an $8 fuse, which is 10 amps in size. It's inside. They're very hard to find. There's two fuses, actually one for milliamps, and we'll generally use this amp port over here. So we want to do a meter correctly so we don't blow the internal fuse, which takes about 15 minutes to change and cost $8. So keep sharp on that. And we'll also use or show in other videos how to actually patch in the meter to a circuit.